We're good? Okay, cool. We got the recording. Hey guys.
Hi.
So let's talk about logic. So you mentioned that you're not. Do you know what logic is?
Well, gosh, I've never heard of it before.
Definitely not a stooge that I've planted in the audience. Thank you.
Female Programmers Club, the best club I've
That's
ever
good. I
been
like
to.
that. So like it's safe to say that, like, I mean, you know, all of you have done some programming, obviously. So you kind of have a bit of an idea of what a specific sort of logic that it takes to think a problem through, write a small program about it, and make that, you know, work. So I think we're just going to go into some of the other, like, nitty-gritty frameworks of different logics.
Right. We're going to talk about logic in more of a philosophical sort of sense. I think if you have a good grounding in like logic philosophically, you can apply it to many aspects of your life, and especially to programming. So we're mostly going to be talking. Logic is basically the steps with which you prove something to be true, or prove to other people that something is true. And when you get into logic, you get into this concept of soundness. And soundness is when your validity and you have true premises, you get to soundness. And you might be confused about what premises are. So I will go into that. When you're talking about logic, you talk about arguments. And arguments are basically statements. But when you're going through the process of logic, there are two different kinds. One of them is premises, or premises. And your premises should, or I guess, and the second one of which is your conclusion. And your premises should prove your conclusion. It should always be steps that get you to your logical end. So let me think of a good example for that. Here, actually, let me pull up a good example. Because I'm a programmer and I'm lazy. And
The subtitle of FTP.
because programmers are lazy. Okay, so we have this first one. So premises 1 is either the maid did it or the butler did it. Premises 2 is the maid didn't do it. So our conclusion is, therefore, the butler did it, because the maid didn't do it. And that's the information that you have presented as well. That's also very important to keep in mind with logic, is it's all based off of the information presented as well. And then it has the second one, which is not logically sound. 99% of all persons who drank the well water became sick. I drank the water, therefore I will be sick. That's not true, because only 99% of the people who drank the water are sick. So to make that logically sound, you would be, therefore, I may become sick. Because that's not 100, the first premise isn't 100% true.
Just by some of the wording of some of these statements, you can already sort of make the connections a bit to how you could throw these into, you know, a programming language. A lot of these are, you know, if statements. Yeah, you've got your, so either the maid did it or the butler did it. You know, that's the same thing as like if maid or, and then your or operators or butler, and then, you know, just as you're going through these, it's a neat little like brain exercise. Because like obviously you've been exposed to logic like this before, so it's just a nice little thing you can have going on in the background of your brain, just like seeing how you can turn this into, like, you know, lines of code just mentally.
And before we get too bogged down in like some technical things, I have some videos. I almost forgot about them.
Really good videos, actually. Yeah, yeah.
Oh.
Yeah.
Did I post them here? No, I didn't.
Oh
good.
no.
Oh no.
YouTube?
It's okay.
Oh, Facebook.
Huh. I've apparently already logged on here. Because it's saved me. And then I'll find where I was talking to Zach. Wait.
I'm the one with
Zim!
I'm the one with the cat.
The one with the cat.
Sure you're not the cat.
Where did I send this to? He is the cat, actually. Facebook.
So you look like a cat.
Yeah, is that what I am to you? Is that all I am to you?
Just a cat.
That's it.
That's pretty cool. Oh no, there's an ad playing.
What? Rude. Oh, I hate
Get
these
out of here,
guys.
Twix.
I know.
That's pretty good.
No.
Twix is really good. I don't want to hear about it.
Yeah, that's true. That's a good point.
Yeah, we don't, that's not part of our thing. That's not what we do here.
It's not what we do here.
I'm not sure.
What's
if this-
Twix now? Hey,
Okay, there we go.
cool.
They get videos this week. It's really awesome.
No, more ads.
Introducing Dial. Now at Kohl's.
I hate this webpage so much.
Plus yoga
Where
pants.
is it coming
Stay
from?
fit.
Why is it coming from inside the It's coming from inside the house.
What's
that?
Superhero teams.
Suppose it.
And don't forget something good. Superhero
Can
too.
someone frame a logical argument about the validity of ads playing on a website?
Be strong.
Why do we
Strong in
have
the
ad
real way,
block?
man.
School doesn't have ad block? What? Okay. There we go.
Hey, alright.
Hey, Lamau.
I like this a lot.
The universe is a big place, huge in fact, and rather complicated. Unfortunately, the human brain is relatively tiny and simple, at least in comparison. To help you survive, it has to work hard to make sense of things. It does have some clever tools to help it achieve this. It can turn experiences into symbols, recall sensations, and identify patterns. But most mental tricks take a lot of energy, and so your brain takes shortcuts. For example, it will seek out ideas that confirm what you already suspect. It will find the ideas of people you trust to be more appealing than those of people you don't. It will take your own experience and treat it as evidence. It will blur the lines between what you feel to be the case and what you know to be the case. Most of the time these tricks serve us so well, we're hardly even aware of them. Sometimes they mislead us. The biases which can be so useful can also blind us. And in a complex world of differing opinions, it's hard to know when to think using shortcuts, when to put some effort into using our heads. Thinking doesn't always need to be hard, however. Logic is a useful way to identify ideas that are likely to be helpful. Logic is a way to combine ideas to come to a conclusion. It's like maths, only it can deal with more than numbers. You've probably used it already. Think about the last argument you had. Did it go a little something like this? But everyone else is allowed to go, why can't I? A logical argument would be structured, all people are allowed to go, I am people, therefore I should be allowed to go. Logic is a useful way to combine established ideas to support the acceptance of a new idea. Looking for logic in an argument can help you decide whether you should agree with somebody or wait for more information.
One small detail I realized in that Aristotle was like 60 when he died. Isn't that like a million back then?
Yeah, he was very old.
Comparatively,
Yeah.
What was the life expectancy? Like 7-8 years tops. Pretty sure.
5.
Yeah, this is the next one. So I got one more video for you guys. And the same people, it's just this cute. Hope you're
Yeah, these are I like the bite-sized chunks that these are too.
right.
Like maths equations, logic has a structure. It looks a bit like 1 plus 2 equals 3. On one side of the equation, we have things we already know or agree upon. On the other side is an answer that's true, so long as the numbers on the other side don't change. In logic, an idea is called a premise, which can be put together with other premises in such a way that they lead us to a conclusion. One premise might say magnets attract iron. The other premise might be this object is made from iron. Without seeing it, you can logically say that the magnet will attract this object. But what if you swap around the information? Say magnets attract iron and this object is attracted to magnets. Can you then say that this object is made from iron? Unfortunately not. It still looks like logic, but the conclusion no longer works. Magnets not only attract iron, but other metals as well, such as nickel. broken logic is called a logical fallacy. This particular example is a formal fallacy, because its form looks similar to logic, but is false. In Latin, and in legal circles, it's called a non sequitur, which means does not follow. It's easy to mistake a logical fallacy for the real deal if you're not careful. People do it all the time, sometimes by accident, and sometimes to fool you. Knowing the structure of a logical argument is important. You wouldn't make the mistake of thinking 3 + 2 = 1. Rules are rules after all. Yet breaking the rules of logic makes it seem it isn't.
If only. So yeah, we'll unless you want to show more of them, we'll post a link for, there's like 6 of them I think, and there's
Yeah.
a whole like channel of things that I think are done in similar styles. I think there's one all about science or something. Which would
Probably,
make sense.
yeah,
Yeah.
I haven't dug too much into
I mean, I've
those
just watched all
videos.
this, but yeah, we'll throw a link up for those because they provide some pretty interesting solid points.
Yeah, absolutely.
Yeah.
So, whenever we're dealing with logic, like they mentioned, you want to make sure your logic is sound. And I'm sure a bunch of you have had class before where they talked about logical fallacies and really went heavy-handed with that. That's good. That's fine. But it's like, how many of you think you would be able to spot good logic if you saw it? Like that's.
I mean,
Me neither.
I mean, it all depends on like the context and stuff, right? You guys have done like simple like riddles or like word problems and stuff like or even now. I mean, you use this sort of stuff in different sort of classes, like all